sewage treatment plant. First of all, I would like to give a brief introduction of our project. So it is a mechanical sewage treatment plant with extended aeration system. It is divided into three phases, which is primary, secondary, and tertiary treatments. The sewage treatment plants allow the bacteria and microorganisms to consume the organic matters in the sewage and then multiply among themselves by providing sufficient oxygen in the treatment plant. The sewage is then decomposed into a stable form which can be easily settled out. The benefits of this type of sewage treatment plant is that it is easy to maintain, odorless, and require a minimum land use. The total cost for the construction of this project is estimated to be 265,789 ringgit and 82 cents. The duration of the project is approximately 14 months. So this is the location of the sewage treatment plant. It is located at Taman Cemerlang Lancar, Saleng, Senai. The developer of this project is Cemerlang Lancar Industrial Park.
Then I will be explained on the contract information of the project. The first one is drawing number. There are two sets of drawing were provided to the contractor to construct the work. The first one is mechanical and electrical drawings from number 1 to number 7, and the second one is civil and structural drawings from number 1 to number 13. The measurement reference used in this project is Malaysia's Civil Engineering Standard Method of Measurement 2nd edition. And the standard form of contract used in this project is PEM contract, which is a common standard form of contract used in Malaysian construction industry. The last one is the procurement method used in this project is design and build.
The project objective is to design and construct a sewage treatment plant with the capacity of 480 PE to accommodate the demands from the adjacent 32 units of 3-story multi-function cluster factories. The project function is to treat the wastewater before releasing it back to the waterways to ensure fresh water source, ensure public health, and prevent environmental pollution. Here we come to the key participants' background. The client is Cemerlang Lancar Industrial Park, a property development company in Taman Impian Emas, Johor Bahru. The contractor is Dataran Tenaga M Sendirian Berhad, a water and sewage contractor in Taman Mount Austin, Johor Bahru. The civil and structural engineer is Wiliakon Sendirian Berhad in Taman Bayu Puteri, Johor Bahru. Lastly, the quantity surveyor is Juru Uko CEM Sendirian Berhad in Taman Munshi Ibrahim, Johor Bahru.
This is the layout of sewage treatment plant. The area is 849.80 meters square. There is a 4,000 mm width premix road is built outside the STP to allow truck access. The STP is guarded by block wall fencing and double lift gate with lock to prevent the entrance of unauthorized people. The tanks and the chambers are well planned to ensure that the wastewater can be conveyed from one tank to another tank smoothly. All of the tanks are rectangular tank instead of circular tank.
Then I will explain on the concept and design of the project. The system that applies in this project is mechanical sewage treatment plants with extended aeration system, which consists of a series of mechanical cluster factories up to 480 population equivalent. In this system, there will be 3 stages of treatment process, which are physical process, biological and chemical process, and lastly, disinfection. The aeration system will use 2 compartments during the secondary treatment process. There is no primary settlement tank, primary clarifier tank, and separate sludge digester used in this system. Then move on to the primary treatment process. In this process, the raw wastewater will be removed with solid materials such as stones, rubbish, woods, sands, as well as grit, through screening and grit and grease removal. There are total 5 units in this process, which are incoming chamber, primary screening chamber, pump sump, secondary screening chamber, and grid and grease chamber. Then the wastewater will be transferred to secondary process. In this process, the wastewater will be removed with nitrate, harmful substances, and organic materials to ensure the sludge produced is harmless. And that the units in this process are aeration tank, anoxic tank, secondary clarifier tank, sludge holding tank, and sludge drying bed. Then the last stages is the disinfection. There is only one unit in this stage, which is disinfection tank. In this stage, the wastewater will be further removed with pathogenic microorganisms and toxic substances to ensure the effluent produced is harmless to be reused. The methods and techniques used in construction of sewage treatment plants will be discussed in 7 aspects. The first one is location of the site. The location of the sewage treatment plants should keep a buffer distance of 20 meters from public areas and habitations. Sufficient allocation of land around the plants is allowed for future expansion. It is also important to make sure that there is no tree grown in 10-meter distance from brickwork fencing. The second aspect is on layout of the sewage treatment plants. The facility is protected from unauthorized entries and accidents with brickwork fencing, and there is a 400-meter wide premise concrete road is constructed for maintenance purpose. The processing unit is built in rectangular flow tanks and connected to pipes. The third one is odor control. The elevation of plants is around 2 to 3 meters below the ground level, and to enable the outside air can be drawn and raised out through the treatment plants in a rising gradient to avoid the foul odor built inside the facility. And the sludge drying bed is covered with a roof system to avoid the dispersion of odor and to protect the sludge from rainwater. The next one is soil erosion control. A 6-meter ditch drain is constructed in earthwork to pump out the stormwater causes and to avoid soil erosion and flooding. The next one is slope stabilization. The excavation work need to be conducted in an angle of repose of 35 degrees. It is important to ensure that the earth is piled without slumping. And then the next one is piling and foundation. The piles used in the project is precast concrete piles of 100 mm times 100 mm. The piles is penetrated below ground soil layer of 5 meters by using pile hammer. The piling is important to absorb the vertical forces from column to the pile tips and to withstand the uneven settlement. The last one is toilet facilities. The toilet is built in an appropriate distance for the convenience of the operators. Next is the design considerations of the sewage treatment plants. The design considerations of the sewage treatment plants are divided into 3 main factors, which are site selection, design of the processing units, and other important factors. The first factor under site selection is distance from residential areas. The site should be located away from residential areas and to allow buffer zone to avoid the dispersion of odor that will eventually disturb the daily life of the residents. The second factor is flooding. The site should be observed with the peak rainfall volume and the possibility of flooding to avoid flooding occurred at the site. The third factor is soil condition. The site to construct the sewage treatment plants can be determined by identifying the soil conditions based on acidity, soil strata, permeability, and capacity to receive the structures. Then move on to the next main factor is design of the processing units. The first is the materials used. The materials used to construct the sewage treatment plant should be based on the standards regulated to ensure that the materials used are qualified to and able to resist the forces. The next one is capacity of the sewage treatment plants. The capacity of sewage treatment plants can be determined by identifying the peak flow of sewage daily. Other method to identify the capacity of the sewage treatment plants is to measure the population size of the area that the plants serve. The third factor on design of the processing units is design of chambers and tanks. All the chambers and tanks should be designed based on the standard, and every chambers and tanks need to be comply with their own standards. This is to ensure that the efficiency of the treatment plants and avoid failure of the processing units. On the other factors, the first one is environmental impact. Before construct the sewage treatment plants, an environmental impact assessment need to be conducted to identify the potential impacts due to construction of the sewage treatment plants to the environment of the site. And when design the sewage treatment plants, the potential impacts need to be taken into considerations and to avoid the occurrence of the problem. The next one is prevailing wind. The sewage treatment plants need to be located prevail from wind direction, and the wind should be blown to the uninhabited areas. The last factor is future expansion. The site need to be designed by allowing for future expansion due to city development. When the city is developed, the sewage treatment plants with higher capacity will be required to afford more sewage flow. Next is the detailed design of the sewage treatment plants. The sewage treatment plants is formed up with 3 major sections of processing units and 1 control unit. In the primary processing units, the units involved are incoming chamber, primary screening chamber, pump sump, bath chamber. These 4 units are constructed together in one section, and the incoming chamber is connected to the last manhole to receive the raw wastewater. And the units in the secondary processing units are secondary screening chamber, grit and grease removal chamber, aeration tank, aeronoxic tank, secondary clarifier tank, sludge holding tank, and disinfection chamber. All of these units are built in one section and constructed with a steel-made walkway to allow the operators to pass through and for the maintenance purpose. Then move on to the last section is the sludge drying bed. There are a total of 4 sludge drying beds are constructed, and they are covered with a steel roof structure to protect the sludge from contact with moisture content. All of the units are built in different depths and installed with different mechanical components according to the standard and the functions of the chambers and the tanks. And the last one is control units. There are 2 rooms in these units, which are blower room and control room. These 2 rooms are not directly involved in the processing of the sewage, but it is important to control the operation of the tanks and chambers.
Next, I will talk about the construction process of the sewage treatment plant. First of all, we have to bring in all the machineries and equipment needed during the early stage of construction. And then we'll perform site clearance to remove all the existing structures if necessary, the debris and waste to ensure that the site is free from any hazards, and the process of construction can begin accordingly. And then we can erect all the site facilities such as site office, toilet, storage, fencing, hoardings, and etc. And then we'll set out for excavation. First, we have to set out the outline of the excavation and also the center lines of the wall according to the layout plan. And then the excavation can be started and by excavating the pits to the required depth as designed by the engineers, and the work shall be started from the deepest area. And then we'll set out the point for piling. We have to locate the point for piling, and then the point is driven accordingly to the specific location, and load test is conducted to ensure that the pile has reached sufficient strength. Next, we will construct all the structures of the treatment unit according to their specification, together with the installation of required mechanical and electrical components. After all of the structures have been constructed, backfilling is done. The excavated pits or the excessive space is backfilled with the selected excavated materials. Finally, we will paint the structures and also finishings, and then we'll perform all the external work, which is the construction of inspection chamber, main gate, drains, lampposts, fencing, and etc. The structures have been fully constructed and also the external work has been done. The testing and commissioning is required to verify the functionality of the electrical components. Then I'll talk about the detailed construction process of the part 1, which is the incoming, consists of the incoming chamber, primary screen chamber, pump sump, and also valve chamber. First, we have to cut, bend, tile, and place all the reinforcement to their respective formwork, and so that concreting can be done. And after the concrete has reached sufficient strength, the formwork is removed. And during this process, the construction joints and water stop are placed between the concrete slab and also between the concrete walls. And there is also opening between the overflow chamber and incoming chambers, and there is another opening between the primary screen chamber and pump sump. In the incoming chamber, there are incoming pipe, static screen, manual pedestal penstock, mount steel grating, and aluminium monkey ladder. In the overflow chamber, there are overflow pipes, mount steel grating. While in the primary screen chambers, there are stopper plates, manual bar screen, perforated container, monkey ladder, and also pipe hand railing. While in the pump sump, there are raw sewage pumps, filtrate pipe, floating switch, monkey ladder, mount steel grating, and non-explosive lights. In the valve chambers, there is check valves and also gates valve. Next, I'll talk about the construction process of the secondary screen chamber, grit and grease chamber, anoxic tank, aeration tank, secondary clarifier, sludge holding tank, and disinfection chamber. The first step is to construct a column at the secondary screen chamber. The second step is to construct the wall and slab of tanks and also chambers. Step 3 is to construct the concrete sloping at the secondary clarifier, followed by the construction of concrete baffles in the disinfection chamber. And then we'll be constructing the beam and walkway. Next, we'll be constructing of brick step. Then we'll construct the reinforced concrete staircase, and finally is the installing of all required pipe works. The installation of M&E works will be followed. We'll move on to the part 3 of the construction works, which consists of the sludge drying bed and also sludge storage area. First step is the construction of ground beam, followed by the construction of the concrete slab, and finally is the construction of the wall. There is a specific requirement for the slab-in sludge drying bed. First, we have to lay the HDP perforated pipe connected to the filtrate chambers. and the pipe is covered by a sand layer and then a gravel layer. Next step is the construction of column, followed by the construction of roof structures. Roof is made up of steel roof trusses and sheet cladding. Next is the installation of mechanical and electrical components. First is the installation of PVC filtrate pipe in the filtrate chamber connected to the drain sump, and also the covering of filtrate chamber with iron check plate, and also installation of galvanized iron sludge pipe from the sludge holding tanks. And finally is the installation of hardwood entrance door at the sludge drying bed.
Part 4. Materials, plant and machineries, and labor use. Some raw materials used are Grade B timber plank and water boil-proof plywood formwork, high tensile reinforcement bars, fabric reinforcements, riddle mix concrete, gravel stones as aggregates, fine sand, precast concrete piles, concrete spacer blocks, PVC water stocks, mild steel dowel bars, steel beams, galvanized iron handrail, alkyd-based and acrylic-based pan, and lastly, high alumina cement in all the internal surfaces of the tanks to resist chemical attack. For the mechanical and electrical materials, firstly, we have the plumbing installations. There are pipes of various functions including the sludge pipe, scum pipe, airlift pipe, filtrate pipe, and so on. They are made up of vitrified clay, ductile iron, high-density polyethylene, galvanized iron, and polyvinyl chloride. Then we have check valves, gate valves, and bore valves. Tube diffusers and disc diffusers are used to supply oxygen. Then we go to the other features in the tanks. Most of them are made up of stainless steel and galvanized iron. Submersible mixer for proper mixing of sewage. Sludge transfer pump is used to pump the recycle-activated sludge, while raw sewage pump is used to pump the sewage from a lower elevation to a higher elevation. Wall-mounted static screen and manual bar screen are used to screen large materials. Removable perforated container is used to temporarily store the waste materials collected from the manual bar screen. Manual pedestal penstock and stopper plate are used to allow or stop the wastewater flow. Baffle board is used to block the floating scum, while scum skimmer is used to collect the floating scum. Floating switches are used to detect the water level to automatically switch on or off certain devices whenever necessary. Manual chain block, lifting device, lifting chain, and guide rail are used to ease the lifting of pumps. Gratings as covers. Other fittings like monkey ladders and non-explosive light are also installed. Plant and machineries used are crawler bulldozer, portable compressor, pile hammer, concrete mixer truck, concrete line pump, water truck, vibratory roller, hydraulic roller excavator, backhoe loader, wheel loader, crawler crane, and truck-mounted crane. On the other hand, the equipment used are dewatering pump, demolition hammer, electrical saw, electric heavy-duty rebar cutter, electric automatic rebar bender, sand blast machine, concrete vibrator, angle grinder, concrete compound sprayer, painting spray gun, and transformer arc welder. Lastly, the labor used are general worker, crane driver, truck driver, plant operator, steel bender, concrete laborer, plumber, fitter, welder, and painter.
Next, I'll explain about the project management system in sewage treatment plant. The first is environmental management. It is carried out to identify a construction project's impacts on the natural environment. In this project, environmental management plan is prepared in the aspect of soil erosion, water pollution, air and noise pollution. There are several acts are referred to, such as Environmental Quality Regulation 2009 and Environmental Quality Act 1974. In the Environmental Management Plan, waste and material management, as well as the Emergency Response Plan are specified under this management. The Emergency Response Plan is prepared to ensure quick response during environmental-related emergency. The actions and the process shall be taken during the emergency need to be established to provide guidance to the worker. The second one is occupational safety and health. In sewage treatment plant project, occupational safety and health, which is OSHA, is important to protect the safety, health, and welfare of the worker who engage in the projects. Occupational Safety and Health Act 1994 is referred in the OSHA management. There are general requirements that need to be fulfilled on site, such as holding must be provided, metal gate at the main entrance, as well as the fluorescent hazard signage must be provided. Besides, the personal protective equipment that need to be provided, such as safety helmet, eye protection, ear protection, and masks, are also monitored under OSHA management. For the welfare of the workers, the temporarily living quarters are prepared on the site. The third project management system in the project is waste management. Waste management is essential to handle and minimize the construction waste in the project. Waste management will refer to the refuse collection, removal, and disposal by law under the Local Government Act 1976. In this project, the wastes are divided into three categories, which are general waste, such as office trays and food waste. And the second one is recycled waste, such as pipes and drums, while the scheduled waste are contaminated chemical drums and waste oil. Waste management shelter is prepared on site to store the scheduled waste. Next, we'll look into how the general waste being disposed of. Firstly, the waste must be stored in the disposal container, such as plastic bag. Later, the waste must be disposed to the dumpster. And lastly, the waste will be collected by licensed general waste collector. The last project management is construction traffic management. Traffic management is adopted in this project in order to minimize the site accident which involve transports. The routes are divided into two types, which are pedestrian route and vehicle route. In traffic management, loading and material storage are well planned in order to provide sufficient spaces for the movement of vehicle and avoid double handling. Protection to the public are also included in this management, at where the security guard is hired and warning signboard is installed to prevent the entrance of unauthorized people. Moreover, drivers shall have related knowledge on safe operation, have ability and experience on operating the vehicle. Apart from the driver, the signaller shall competent, and trained. In conclusion, STP is important to human societies and environment as it's able to treat the wastewater before being eliminated into river or sea. In order to sustain the increasing of population in our country, more advanced STP shall be adopted in order to bear the amount of wastewater being eliminated from human activities. Thank you.